Hi, Ms. Zimmer here with a couple of extra problems from section 12.4. These two problems may appear in your homework, and I thought they could be a little tough. So I wanted to do both of them for you. So the first one has two circles. It's got two tangents, a secant, and the circles overlap. So let's try to find x and y. Well, first I'm going to ignore this original circle, the first one on the left, and I'm going to focus in on the tangent. And remember, our tangent is squared. And then take our secant here. The external secant segment is 6. It's external to this circle. And multiply it by our total secant, 6 plus x. So we get 100 equals 36 plus 6x. We get 64 when we subtract that 36 equals 6x. And when we divide, we get 10 2/3. You're like, well, I am just going to write 10.6 or 10.7 rounded to the nearest 10. You can't quite do that here because we're not finished with the problem. So leave it in fraction form. You could do an improper fraction. You could do 64 over 6. You could reduce it. You could do 32 over 3. But it needs to be in fraction form in order to solve for y. Now, let's flip over here. Y is the tangent. 6 and x are that's on our secant. But now we know that x value is 10 2/3. And it's really helpful to have your calculator with fractions in case you are feeling a little bit queasy about doing fractions and multiplying or adding them together. So now we've got y squared. That's our new tangent over here. And 6 is our external secant segment here. But 6 times x will be now 6 times 10 2/3. 6 plus 10 2/3. So does that mean that this is 16 2/3? Yes. Now, if you remember how to use your calculator in fractions, you can do 6 times 16, fraction button, and 2, fraction button. Oops, I forgot to hit times. I hit the fraction button too soon. 6 times 16 and 2 fraction button thirds. So it looks like this. Okay, those little sort of L's are from hitting that fraction button. Equals. It comes out to 100. Yay. So y squared equals 100. Y is 10. If we had rounded off this number, we would never have gotten 10. We would have gotten something close to it, and it is exactly 10. In fact, it comes out that those two tangents are equal to one another because they're in the same equation. They're both equal to the same secant segment times the segment. Okay. Now let's flip over to this picture. I'm going to get some of this out of the way. Now, here we're looking for x and y. First, we're going to recognize something that we learned from chords and arcs. If this arc is equal to this arc, then that means this segment is equal to this segment. And if it's bisected, that means it's perpendicular. If it's perpendicular, that means here we have a right triangle. And if we have a right triangle, we can find x by saying x. And by the way, if this is congruent, then this is also 8. X squared, one leg, times 8 squared is equal to 15 squared. So now to solve that, x is equal to the square root of 15 squared minus 8 squared. So 15 squared minus 8 squared, I get 161. On the inside of that, or the square root, is 12.7. This time we can round because we have no choice. Now, what we can do for the solving of y is leave it as the square root of 161 and see if there's another choice, which there won't be, but sometimes we don't know that until we solve the problem. So in this particular one, we've got one segment crossing another, or one chord crossing another at that value. So 8 times 8, those are the values on the first chord, is equal to 161, the square root, or you could put in 12.7 if you wish, times y, because those are on this chord. So we have 64 here equals y times the square root of 161, divide by the square root of 161. Sorry if it's falling off the screen a little bit. There we go. And y is equal to this value divided, so 64 divided by the square root of 161. And we get 5.0, 5.0. And if it says round to the tenths, the 0 does matter. My math lab will sometimes not count it right if you don't include that 0.0. Okay. And it will come out to the same thing, 5.0, even if you did 12.7. So you're good either way in that problem. So I hope these 2 additional problems were helpful to you. I'll be back in a while with section 12.5.